Hi again. So, this is higher factoring part 3, factoring expressions with rational exponents. So that, of course, is exponents that are fractions. Crazy. So, the previous sections have mostly been review or expansion of material from previous courses. This is a new twist on subsection 1, the greatest common factor. The premise or the idea is exactly the same. However, we just expand this now to fractional exponents. Okay, so just as a quick recap, so in this polynomial, 9x to the fifth minus 5x cubed plus 3x squared, okay, the GCF is x squared. You can't pull out any numbers from the 9, the 5, and the 3, and x squared, or 2, is the smallest exponent that we can pull out with the x's. So again, we're always going to pull out the biggest number possible and the biggest exponent from all chunks, which is, well, technically the smallest number of exponent from all the terms. So if we have a look at example 1, okay, first things first, we notice that we can pull out a 2. Where's that going? Okay. There it is. Okay. Sorry about that. Alright, so we can pull out a 2. Now, if we look at the x's, okay, so x to the 3 halves, x to the 1 half, x to the negative 1 half, the smallest variable is x to the negative 1 half. Okay, so that's the one we pull out. Okay, so now 2 divided by 2, okay, that just cancels. Okay, what about the x's? So x to the 3 halves minus x to the, or divided by x to the 1 half. So let's just write it over here, so just once. X to the 3 halves divided by x to the negative half. Okay, remember when you divide powers, you're subtracting exponents. So it's 3 halves minus negative 1 half. Well, hey, that's x to the 4 halves, which is just x squared. Okay, so hey, interesting. So that's x squared. 14 divided by 2 is plus 7, and then x to the half divided by x to the negative half. Half minus negative a half is just x to the 1. Okay, and then minus 18. Whoops, sorry. Dividing by 2, so that is 36 divided by 2. Yeah, that's 18, sorry. Okay, and then, of course, we took the x to the minus half out, so there you have it. Okay, now, one thing you do have to check, look, that makes a quadratic, and that particular quadratic is also factorable. Okay, so factors of 18 subtract to 7, well, that's 9 and 2 plus 9 minus 2. So that is the fully factored version of this. Alright, so if we have a look at number 2, there's no coefficient that we can factor out of the 5, the 7, and the 2. Right, there's nothing we can factor there. The lowest exponent is 2/3, so we can factor out that. Okay, so you get 5. Alright, so then we get the, we're subtracting 2/3. So 8/3 minus 2/3 is 6/3, which is just squared. Okay, and then minus 7. Okay, 5/3 minus 2/3, that's just 3/3, which is x to the 1. And then plus 2. Okay, so again, we have to see if that factors, and of course it does. So 2/3. Okay, so that's going to be 5x and x. And let's see, we need factors of 2 and 5 that add to 7. Okay, well, that's this guy here, so that's the 1 goes here, the 2 goes there. Okay, factors, and they're both negative. There we go. Okay, so that is that guy factored up. Okay, if we have a look at number 3 here. Okay, 3 is very tricky. There's a couple of different pieces. Okay, you notice that there is a monomial term kind of there, multiplying a binomial term on each chunk. So basically, well, just have a look. The biggest coefficient we can take out is 5. The biggest x we can take out of both is a 2. Of course, that's the smallest exponent. And then you also have this 3x minus 1 on both chunks. So we take out the smallest exponent of that, which of course is negative 3/2. So that's the GCF. It looks mean, but it's what it is. Okay, and then you know, if you really want, you can make square brackets just because it's kind of bigger and there's this binomial thing. All right, anyways, have a look. So 5 divided by 5, okay, that cancels. X cubed divided by x squared is just x. Okay, awesome. Now then you have the 3x minus 1 to the negative 3/2, that whole thing factored out. Okay, so then we've got the plus sign. So 10x squared divided by 5x squared, that is just a 2. Okay, and then 3x minus 1, 3x minus 1 to the negative 1/2, and we took out negative 3/2. Okay, well, subtracting a negative, so negative 1/2 minus negative 3/2, hey, wait a second, that's a plus, so that's 2 over 2, so this is just to the 1. Now that's going to happen a lot when we come up to something called chain rule and product rule for derivatives later on. So anyways, the idea here is we can simplify inside the big square brackets. So have a look at this. So 5x squared, that's still there, 3x minus 1 to the negative 3/2. Okay, and then this part, that just rainbows. So you'd get x plus 6x minus 2, which of course reduces to 7x minus 2. 5x squared, 3x minus 1 to the negative 3/2. Okay, and that is good. That's just a bracket, remember? Okay, good enough. All right, so that's that guy. Now, tell you what, I'm running out of room here, so I'm just going to transfer this over to the next page really quick. Okay, so here, make that bigger. Okay, save. There we go. Okay, we'll just paste that in here really quick. Sorry, guys. You know, the reason I wanted to do this is because this one, sorry, it's a little blurry now that it's bigger, but that's okay. How we're going to do this, or what we're going to do with this, look, there's clues as to what this is doing for us. Look, it's a binomial. There's only 2 chunks. Well, that's going to lead us to think maybe a difference of squares, or it's plus here, so maybe a sum of cubes, something like that. So let's factor and see what it turns into, because it'll be interesting. So 27 and 8, we can't do anything fancy with those, but look at the x's. The smallest exponent on the x is x to the minus 1/2. Okay, the smallest exponent on the y's is just y. Okay, so that's the GCF. So the 27 stays there. Okay, negative or 11/2 minus negative 1/2 is 12/2. Okay, so 12/2 is x to the 6th. Okay, plus 8. Okay, we took out the x to the negative 1/2, and y to the 4th divided by y is y cubed. Oh goodness, this is a sum of cubes. Well, that's cool. So we have to figure out or remember the pattern from last section. So negative 1/2 y. Okay, so we have to cube root the 27. So cube root of 27 is 3. Okay, cube root of x to the 6th is x squared. Okay, remember the binomial for these things, it has the same sign, right? That just carries down. Awesome. And then the cube root of 8 is 2. And the cube root of y cubed is just y. So that's the binomial part. Now for the trinomial part, Remember, it's the first chunk squared, so that's 9x to the 4th. Okay, the sign changes, so negative, and then it's those two things times together, like these two things. Okay, so 3x squared and 2y makes 6x squared y. Okay, and the last one is just this chunk squared, so that's going to be plus 4y squared. And there you have it. So that is factoring with the fractional exponents, and when you do that, quite often you can factor what's left, either a sum or difference of cubes. And on this previous page, like, there was just a lot of quadratic factoring as well. So every now and then these things can, like in number 3, the part inside the brackets could simplify and combine like terms. So just some things to be aware of. Thanks, guys. That's it for this subsection. The formative assessment is coming up. It has similar questions to this. Again, call if you need anything. Thanks.